Imagine chasing a cosmic duck across the solar system.
A cosmic duck.
Yeah, not like some intergalactic race or anything.
Right.
It's the European Space Agency's Rosetta mission
Ah.
on the hunt for Comet 67P Churyumov-Gerasimenko.
Wow.
They spent a decade in pursuit,
A decade.
got up to it, and then tried to land on this tumbling, oddly shaped icy body. Talk about ambition.
That's incredible.
Welcome to Cosmos in a Pod, Space and Astronomy series.
Glad to be here.
We're diving deep into this incredible journey of Rosetta and its lander Philae,
Okay.
exploring some surprising discoveries about this ancient relic from the early solar system.
Sounds fascinating.
So we're not just talking about a quick flyby here.
No.
What was the European Space Agency really hoping to achieve with such a daring mission?
Well, the Rosetta mission was all about deciphering the secrets held within these icy wanderers.
Okay.
Imagine a cosmic Rosetta Stone.
I see.
But instead of unlocking ancient languages,
Right.
it's giving us clues about the very building blocks of our solar system.
Wow.
And maybe even life itself. They wanted to study the comet's composition,
Sure.
understand its potential connection to the water and organic molecules we find on Earth,
Yes.
and basically get a glimpse into the solar system's baby pictures.
The solar system's baby pictures.
Yeah.
I love that analogy.
Yeah,
Okay, that's a pretty awesome goal.
it is.
But let's back up a bit.
Sure.
You mentioned Rosetta chasing this comet for 10 years.
Yeah.
What did that journey actually look like?
Well,
Was it just a straight shot across the solar system?
not quite.
Oh.
Rosetta's journey was more like a cosmic pinball game,
Pinball.
using the gravity of Earth and Mars to slingshot itself toward its target.
Wow.
It launched in 2004
okay.
and took a whopping 10 years to reach the comet in 2014.
10 years.
To put that in perspective, think about all the things that happened here on Earth
Yep, that's a long time.
in that time frame.
10 years in space. I can't even imagine. Did
yeah.
Rosetta just keep flying that whole time?
Actually, there's a fascinating detail you pointed out in your research.
Oh.
To save energy, Rosetta went into a deep space slumber
A slumber.
for nearly 3 years.
Whoa.
This wasn't some unplanned nap.
Okay.
They intentionally put the spacecraft into hibernation
Wow.
to conserve power during the long, quiet stretches of the journey.
So it was like a space age power nap.
Exactly.
That's incredible.
Then in January 2014, like a cosmic alarm clock going off,
Uh-huh.
Rosetta woke up
It woke up.
and prepared for its rendezvous with the comet.
Okay, so after this incredible journey, Rosetta finally reaches Comet 67P.
Yes.
But now comes the truly daunting task.
Landing on it.
Landing on
Yeah.
it. And you're not talking about some smooth spherical asteroid here.
Right.
You mentioned an oddly shaped icy body.
Comet 67P is a bit of a cosmic oddball.
Okay.
It has this very distinctive,
Yeah.
almost duck-shaped structure.
Shaped like a duck.
Imagine trying to land on a giant rotating duck.
Huh.
Made of ice, dust, and who knows what else. It has cliffs, craters, boulders. A real challenge for any lander.
Yeah. Not exactly a welcoming landing strip.
Definitely not.
But it's not just the shape that makes this landing tricky, right?
You're absolutely correct.
Okay.
Remember those physics classes you may or may not have slept through?
I think I remember a few things.
Gravity plays a huge role here. Comets have incredibly weak gravitational pull compared to planets.
Okay.
Landing on 67P is like trying to stick a magnet to a bar of soap.
A bar of soap.
It just doesn't want to stay put.
I see.
Then you factor in the extreme temperatures,
Oh, yeah.
a surface covered in dust and ice,
Uh-huh.
and the general harshness of the space environment. Talk about a cosmic obstacle course.
It sounds incredibly difficult.
It was.
So how did the European Space Agency even approach a landing under those conditions?
Yeah, good question.
What was their game plan?
That's where Philae comes in.
Philae.
This wasn't just some passive lander.
Okay.
They equipped it with harpoons and ice screws
Harpoons?
designed to anchor it to the comet's surface.
Seriously?
The idea was to fire these harpoons into the comet
Wow.
to secure Philae,
Okay.
accounting for that incredibly weak gravity.
Harpoons. That seems a bit out there.
It does, doesn't it?
Even for space exploration.
It might sound a bit crazy,
Yeah.
but remember, we're dealing with uncharted territory here.
True.
They needed a creative solution to overcome these unique challenges.
I think.
And the harpoon system was their best bet. It was a high-stakes gamble,
It sounds like it.
but one they were willing to take to make history.
So did this audacious harpoon strategy work?
Whoa.
Did Philae actually manage to land on this spinning cosmic duck?
It did. On November 12, 2014, Philae became the first spacecraft to touch down on a comet, a truly historic moment.
That's incredible. Landing on a comet with harpoons, no less, has to be one of the most daring feats in space exploration history. But I have a feeling it wasn't exactly a smooth landing, was it?
You're right to suspect that while Philae did touch down, things didn't go quite according to plan. The harpoons didn't fire as expected,
I don't know.
and instead of a graceful landing, Philae ended up bouncing across the comet's surface
Bouncing.
like a rubber ball.
A cosmic bounce house that must have been a nerve-wracking experience for the mission team.
Absolutely. But even though Philae ended up in a less-than-ideal spot, tucked away in a shaded area, it still managed to accomplish some incredible science in the roughly 60 hours
60 hours.
this battery lasted.
Wait, only 60 hours? That doesn't seem like much time after that epic 10-year journey.
I know it sounds like a cosmic tease,
Yeah.
but remember, Philae was relying on a battery
Right.
that was meant to be recharged by solar panels,
Uh-huh.
unfortunately being stuck in a shadowed area.
Ah, I see.
Limited its power supply still in those precious few hours, Philae managed to analyze the comet's surface composition
Okay.
and sent back some fascinating data.
Okay, so even with the landing hiccups and limited battery life, Philae still managed to do some science.
It did.
What did it actually find out in that short time?
You noted in your research that you were really interested in the possibility of comets being a source of organic molecules
Yeah.
essential for life.
Yeah.
Well, this is where things get really exciting. Philae detected a variety of organic molecules, including some amino acids,
Amino
the
acids.
very building blocks of proteins, which are essential for life as we know it.
Amino acids on a comet, that seems like a pretty significant discovery.
It is. This finding supports the idea that comets might have played a role in delivering these crucial ingredients to early Earth,
Wow.
potentially contributing to the rise of life on our planet. Philae also detected a mix of ice dust and complex hydrocarbons,
Okay.
giving us a snapshot of the comet's diverse makeup.
So despite the drama of the landing, Philae delivered on its promise of revealing some of the secrets hidden within this comet. What about Rosetta? Was it just watching from a distance while Philae did its thing on the surface?
Not at all. While Philae was busy on the surface, Rosetta was hard at work orbiting the comet, creating detailed maps of its surface, studying its activity, and observing how it changed as it got closer to the sun.
That makes sense. Comets are known for those spectacular tails they develop as they approach the sun. So what did Rosetta observe about Comet 67P's activity? Was it like a cosmic fireworks show?
In a way, yes. Rosetta witnessed 67P becoming more active as it neared the sun with jets of gas and dust erupting from its surface.
Okay.
But one of the most intriguing findings was about the water on 67P.
The water. What was so special about it?
Well, it turned out to have a different flavor than the water we find on Earth.
Flavor. I'm not sure I follow.
Think of it like this. Water molecules can have slightly different flavors based on the types of hydrogen atoms they contain.
I see.
Scientists call this isotopic composition. The water on 67P had a different flavor than Earth's water,
Okay.
suggesting they came from different sources.
So does this mean comets like 67P weren't the primary source of Earth's water like scientists initially thought?
That's a big question that Rosetta's findings have raised. It suggests that the story of how Earth got its water is more complex than we previously assumed. There are other possible sources like asteroids,
What?
or even processes that happened during Earth's formation. It's a fascinating puzzle that scientists are still trying to piece together.
It's amazing how studying a single comet can open up so many questions about our own planet's history.
Yeah.
But Rosetta's mission wasn't over yet, was it?
You're right. Rosetta had one final poignant chapter to add to its incredible story.
What happened?
In 2016, it ended its mission with a controlled descent onto the comet's surface, joining Philae in a final cosmic embrace.
What a dramatic finale, a fitting end for a spacecraft that had spent over 2 years dancing around this fascinating comet. But as we transition into the final part of our deep dive, curious, what do you think is the most enduring legacy of the Rosetta mission?
Rosetta's legacy goes beyond its specific discoveries. It showed us that daring missions to these distant, enigmatic objects are achievable. It changed our view of comets, revealing their complexity and beauty, but perhaps most importantly, it reminded us of the power of human curiosity, our relentless drive to explore the unknown and the endless possibilities that lie waiting for us among the stars.
Beautifully put. So as we prepare for the final leg of our deep dive into the Rosetta mission, I'm left wondering what other stories do comets have to tell? What other secrets are hidden within these icy wanderers? And what new questions will we uncover as we continue to explore the vast expanse of our solar system and beyond?
Those are the questions that keep us looking up at the night sky, filled with wonder and a thirst for discovery. Join us in the final part of this episode as we explore the broader implications of Rosetta's findings and what they might tell us about the universe as a whole.
Welcome back to Cosmos in a Pod. We've spent this episode exploring the incredible story of the Rosetta mission, from its 10-year chase across the solar system to its groundbreaking discoveries on Comet 67P.
We've delved into the comet's strange shape, its composition, the drama of Philae's landing, and the intriguing findings about organic molecules and water.
It's been quite the journey, but as we reach the end of our deep dive, I want to take a step back and consider the bigger picture. What does Rosetta's story tell us about our place in the universe? How does this one mission to a single comet impact our understanding of the cosmos as a whole?
You highlighted something really interesting in your research, the idea that Rosetta represents a shift in perspective. It's moved us from seeing comets as simply icy leftovers from the solar system's formation to recognizing them as complex worlds with their own stories to tell.
I like that, comets with stories. What kind of stories are we talking about?
Well, think about it. Comets are some of the oldest objects in our solar system. They formed billions of years ago during the very dawn of our planetary neighborhood. By studying them, we're essentially unlocking a time capsule, gaining insights into the conditions that existed when planets were forming and the solar system was taking shape.
So Rosetta is helping us understand our own cosmic origins, our place in the grand scheme of things.
Exactly. It's giving us clues about the processes that led to the formation of Earth and the other planets, the ingredients that were present in the early solar system, and the events that shaped our cosmic neighborhood.
And we can't forget those intriguing organic molecules. Philae found those building blocks of life. Does Rosetta's discovery change how we think about the possibility of life beyond Earth?
Absolutely. If comets, which are relatively common objects in the universe, can carry these crucial ingredients for life, it really makes you wonder if life itself might be more widespread than we once thought. Perhaps the seeds of life are scattered throughout the cosmos, carried by these icy wanderers.
It's a mind-blowing concept to consider. But Rosetta didn't just provide answers, did it? It also raised new questions like the mystery of Earth's water and the diversity of comets themselves.
That's the beauty of science. Every discovery opens up new avenues of inquiry, leading to more questions, more research, and a deeper understanding of the universe. Rosetta's findings have spurred a new wave of exploration, with missions being planned to rendezvous with pristine comets, analyze their composition, and even bring samples back to Earth.
It's like Rosetta has sparked a cosmic treasure hunt, inspiring us to seek out these ancient objects and unlock the secrets they hold.
And that sense of wonder, that drive to explore, is at the heart of what makes us human. Rosetta's legacy goes far beyond its specific scientific findings. It has reminded us of the power of human ingenuity, our ability to overcome incredible challenges, and the profound impact that a single mission can have on our understanding of the universe and our place within it.
It's clear that Rosetta's story is far from over its discoveries, will continue to fuel research, inspire new missions, and shape our understanding of the cosmos for years to come. It's left us with a sense of wonder and a thirst for more knowledge, a desire to keep exploring and asking the big questions.
And those questions, where did we come from? Are we alone? What else is out there? What drive us forward, pushing us to reach further into the depths of space, seeking answers and uncovering new mysteries?
Well, on that note, I think we've reached the end of our deep dive into the Rosetta mission. We've journeyed across billions of kilometers, landed on a comet, and explored some of the most profound questions about our place in the universe.
It's been a privilege to share this journey with you.
We hope you've enjoyed the ride. Don't forget to follow and subscribe to Cosmos in a Pod for more fascinating space adventures, and check out our YouTube channel for stunning visuals from the Rosetta mission. Until next time, keep looking up and keep exploring.